So the first way to make money was with X-rays, but with X-rays was with performances. But was this really the way to work? It soon transpired that people would be amused by seeing their own hand once, but rarely twice, and certainly not three times. It just wore off very, very quickly, and the performances were really a one-day wonder. And if you wanted to make a living with X-rays, you had to think of some other way to do it. And so let's try and think about this. I mean, how can you make money with X-rays? And these are questions on the slide that one should always ask when innovating in a startup situation. Where is the demand? Who is the customer? What is the competition? What would the customer actually pay for? How much can you charge? How many customers can you get? What are your costs? And does it cost more to supply than you can charge? And we will actually show these, show some answers to these questions in the course of the lecture. We're gonna go through the MIT, the market implementation technology for X-rays, and let's start with the technology. The photo here on the right shows the structure of an X-ray setup in 1896, and so there are four bits that you can see on this slide. The one to the right we're ignoring. The second from the right is the battery. So it supplies a current, and you can see the two wires going from it to the induction coil, which is the second from the left, or the third from the right. And in fact, the two wires are going first to an interrupter, which I'll talk about more in a minute. And then the interrupter makes the DC current from the battery into an AC current, and then the induction coil is actually a step-up transformer yielding a higher voltage, because you need very high voltage for the X-ray tube to operate. The issue really is that inside the evacuated glass tube, you need the current to jump through the vacuum, and that'll only work if you have a high voltage. And then you can see on the left, so the left part of this slide, so there are four parts, and on the left, you can see in the middle is the X-ray tube, and you can see the sort of rays, stipulated lines going down from it, and then there's a hand which is lying on a box, and the box will contain, in this case, actually probably a photograph or a photographic plate, not actually a screen as it says there on the left. But you could use a screen in those days, or you could use a photograph. With the screen, you could see the image immediately, but with a photograph, you would well, for one thing, if you had very weak radiation, you could over time get an image, and also you then had a record that you could keep, which will turn out to be important. And let's talk about implementation first. Now, one of the issues when you were dealing with X-rays was to develop best practices. And there were different kinds of practices being developed. One of the first things that people did with X-rays was to take photos of, say, needles that had been stuck in a hand, which works very nicely with X-rays because needles are made of metal, and metal absorbs X-rays very well, and the soft tissue of the human body absorbs X-rays less well, and the bones actually absorb pretty well, but metal absorbs even better than bones. So when you had metal inside the human body, most typically in the hand, It could be a bullet also, of course, but you know, a needle or a bullet. It was really quite easy to take an X-ray photograph because the contrast between the soft tissue and the needle was so large. So it was easy to get a good image of that on a photograph or indeed on a screen. Broken bones were also very well suited to X-rays because bones, the contrast between bones and soft human tissue is also pretty large. Still, with both these two things, you had to get the trick to work. You had to get the experiment to work. You had to know how to operate the X-ray tube. You had to know just how well evacuated it had to be. You had to know how to operate the interrupter and so on. And it required practice to learn to do this, and then you began to develop best practices so that you could follow a particular routine and you would get the X-ray to work. And when it then comes to even more difficult images, such as taking photos that should reveal something about the human lungs, and tuberculosis was the biggest disease in the 19th century. So it was very desirable to take photos of lungs. But that is actually quite difficult because to show the difference between different kinds of human tissue, so this would be the lungs as opposed to, say, the heart and so on, it was very, very hard to get exactly the right kind of radiation and contrast to get this to work. And then people were beginning to make movies, and they were beginning to make stereoscopic images, which is basically images taken from two slightly different angles, which is what we do with our eyes. And we get a sense of depth from having two slightly different angles all the time, and you can get that also in a photograph by taking two photos from a slightly different angle. That was also a great form of entertainment in the 19th century, where you could look through stereoscopes they were called, and you would look at two photos that had been taken from a slightly different angle, and looking in at these two photos, you would look at one photo with one eye and one photo with another eye, with the other eye, and you would sense the depth, and that was a tremendously exciting thing for people to do in those days. So that was developed for X-rays too. And another aspect to implementation is that you would actually have to convince the customer that this was a useful thing. And so who are the customers here? Let's try to think about this. Well, if we're talking about broken bones, say, the customer would be a medical doctor who had to diagnose a broken bone, and they would then you would then have to convince these medical doctors that it was a useful thing to have an X-ray photograph or an image on a screen, that the doctor would be helped in his or her, well, actually his diagnosis. There were barely any female doctors in those days. And a part of the technique, or no, should we say the social technique, part of the way to convince the customer was that the MD himself was left to interpret the image at hand. If you were going to take away any kind of interpretative power from medical doctors, they would not have accepted the X-ray technology as novel. Another aspect of importance was that if you wanted medical doctors to use X-rays, the setup had to be simplified. It had to be, again, it had to work every time, but it should also not take so long to do, and it should not involve great attention, because you just want to take this photo and move on with your activities. You also then had to teach doctors the physics of radiation, and in those days That was kind of an esoteric topic and not something that you would have learnt about in medical school, because why would you have? It wasn't of any great reason prior to something like X-rays. And of course, another very important thing to think about if you want to convince a customer is the price. It had to be cheap. It had to be efficient. So there were lots of things that you needed to do with this technology to make it amenable to the customer. Summarize what we've just been talking about again. We're talking about the iteration of market implementation and technology, and this kind of iteration can work like this when it works, when things are good, when innovation is successful, then it can work like this. Improved vacuum tubes make for a better diagnosis, which convinces more doctors. More doctors make for a larger market, and a larger market makes for more money for development and technology and implementation, which leads to better diagnosis, and so on and so on. So many iterations where you get better and better at something that where implementation, technology, and market work together, and that this is what we're talking about, the iteration through transactional experiences between market, technology, and implementation.